Great. Okay. So, welcome. I'm going to be talking today about supply chain security and some new ways to defend the supply chain in real time. I will be nerding out a little bit. I offered to give this talk because mostly I just think it's kind of interesting. There's lots of weird quirks and things in the ecosystems that make this a somewhat complex problem to solve, or at least finicky. I'm going to be walking through kind of how we went about approaching the problem. I'm going to be talking a little bit about the threats themselves. And then I'm going to be basically dumping on package managers and all the weird quirks that they have. So hopefully that's engaging. I'm going to be really diligent about being on time on this. I haven't timed myself perfectly, so feel free to heckle if I'm bumping up against the next talk. Okay, I am Dale. I work for Socket. You'll see our booths here. Maybe you've heard of us otherwise. I'm on the engineering team, working on a product that is a real-time package firewall. I kind of have a background in dev tooling, building compilers, building frameworks, that sort of thing. That's kind of been my jam. More recently, moving into the supply chain space and kind of the dev tooling around that. So that's my context coming in. I'm not necessarily a security person. I am a dev that has moved into this and have some empathy for the engineers that are engaging with these systems that are hopefully keeping people safe. All right, so I'm going to start here. Every developer trusts their package manager. It's something they're interacting with dozens of times a day. It's part of their flow. It's not something that is really even a conscious choice often. It's just part of what happens. The package manager trusts what's in the registry. Every package you install, every dependency that's pulled in is an act of trust. Because developers trust the registry to get their jobs done, so can attackers. Attackers can trust the registry to get their jobs done. So it's a really interesting vector. It's kind of like a hard problem to solve simply because we can't impose the constraints to keep everything perfectly safe, because then it would be impossible to develop software. So it's sort of like a cat and mouse game where we really want to try to engage with the latest attempts to compromise these companies and these developers, while trying to leave a path open for developers to actually get their job done. So that's my angle coming in. So the question is, what happens when you run npm install? You're requesting code from a public registry. It's being executed oftentimes immediately, either as part of the installation or pulling down that package, and sometimes at runtime. Either way, there is kind of a threat that may be imminent. If you're running in dev mode and you have some software running and you pull down a dependency, it doesn't really matter if it's there as part of a post-install step or if it's there as part of the the runtime code itself. Either way, it's going to be immediately invoked. And developers sort of trust this implicitly. This is, like I said, the bread and butter. So your package manager asks for packages. The registry sends them. Your machine extracts these things and just sort of implicitly trusts this arbitrary code that anybody could have thrown up on these registries. There is no checkpoint. There's no approval process, barring some security tooling. And the code runs before anybody has read it. In fact, most of the time, as many of you know, nobody reads the code. It's just installed and pulled in. So kind of ripe for abuse, ripe for compromise right there. And obviously, this is something that attackers have been escalating as they've figured out how to weaponize this trust. So I'm quickly going to go over the attack vector. So oftentimes with these things, there has to be some initial step where the developer is pulling something in either transitively or themselves. So sometimes it's typo squatting, meaning that you're trying to type Lodash or something like that, and you're getting a different package because you pressed the wrong key or in the wrong order or something like that. So that's a pretty common one. Account compromise. Now this is where a lot of these things are propagated through the ecosystems, is through account compromise. So I'm going to be talking about that a little bit more. And dependency confusion. So say you have a scoped package internally, and then somebody realizes through some leak of information that this package is used internally and it's not actually reserved in the public registry. Well, then you can go register that package and put something compromising there, and people might pull it in if they don't have their computer set up perfectly, right? So a great example of this recently was Shai Hulud. 500 packages compromised through a chain of compromises. And we have some kind of companies that are of good repute that got compromised by this, and that helped proliferate this through the ecosystem. You have maintainer accounts that were compromised through this kind of chain of events. And you have these patch version bumps that look benign, that look like any other thing, that are automatically installed if you're just not using a lock file or if you're just happening to be updating your dependencies. Either way, it looks benign, and unless you're reading through every line of code, you're not going to be observing that this is happening. So I thought this was cool. I thought it was very intriguing how this all came about. Really sophisticated. The sophistication of these attacks has been ramping up, requiring some different ways of engaging with the problem. So first you have like this pre-install loader that when this dependency gets pulled down, it's starting to run arbitrary code in the background, so it's not obvious, it's not blocking. There might be a process running, but unless you happen to be looking at every single process running in your machine, if you're a masochist, you wouldn't notice that, right? So it's just running in the background, and it's running in a privileged mode because these are developer tools. Next up, you have the CI pivot, so that starts to segue things into extracting information in these CI environments that relate to publishing of packages. Then you have the credential harvest, so that is where, I'm going to talk about this a little bit more, but where the secrets that are running on these machines are just kind of collected up. And then you have the propagation. So you have the tokens that are captured internally in that like harvesting phase. And then these secrets are being exfiltrated using some mechanism, right? And then there's ecosystem spillover, which was a unique aspect of this particular campaign, where it's really fun to rag on NPM, and obviously that's where a lot of these things happen. But in this particular case, it's spilled over into Maven. So it's not a unique problem to NPM per se, it's just that NPM is wildly popular, and that's makes it ripe for abuse. Okay, so, and the word worm propagation, I'm kind of indicating that this goes back to the beginning now, so that anybody that pulls down a compromised package can go through the same chain. And that's why Shai Hulud was so problematic. It's because through this process, multiple maintainers in a chain or in a tree, I suppose, were compromised. And then all these packages were compromised. And then anybody basically installing with any project had the opportunity to be compromised. So I want to focus a little bit on this first step, where the thing was downloaded, something bad happened, and that kicked off this chain of events. That's the problem I'm thinking about, and we're going to be talking about today. I'm already 9 minutes in, so I'm gonna skim a little bit, guys. We're doing this live. All right, so we have the pre-install loader, and I'm not gonna go through all this. I'm just gonna kind of put this up on the screen. This was interesting because it involved Bun. Even if you weren't using Bun locally, it like pulled down a binary, and things were happening behind the scenes that you may not even been familiar with. So that was an interesting aspect of this. As probably many of you know, once when you're running these things in CI, there have to be secrets injected somehow. And That's either for publishing, for interacting with external systems, or any of these things. And so once the local dev machine is compromised, or maybe CI is compromised directly through a dependency update, there's this opportunity now to interact with these secrets that are running in CI, because the CI implicitly trusts the developer, and the developer implicitly trusts the registry, and the registry is where the attack happens. All right. And then exfiltration. There were some really interesting things about this. So I'm going to pause here and not breeze by too quickly. If you're not familiar, Truffle Hog is a tool that can kind of scan your local system and look for secrets that might have been exposed. And so it's actually a security tool that in this particular case not only looked benign, it looked beneficial. It looked like something that should have been happening. Maybe MDM pushes this out and runs it on local systems so that your IT admin can know if these secrets are being compromised. So there's an actual security tool being used for the compromise in this particular case, which kind of it brings a level of sophistication that we may not have actually seen in previous campaigns of this kind, anyway. And then it's just like it's grabbing all the secrets it can, right? It's uploading it eventually to a GitHub repo of the compromisee's account, and then it uses some very basic obfuscation where it's like triple base 64 encoding these things when it's uploaded. So it's really not obvious. You might decode it and be like, oh, it's still just random letters and numbers. I'm not really sure what's going on here, but it doesn't look concerning. So very, very trivial, but obviously good enough level of obfuscation with the actual exfiltration that went on. And then the word propagation. I'm gonna skim through this a little bit. Things happened. It spread. It was bad. That was sad. That's a summary for that slide. Yeah. Okay. So and then the cross ecosystem spillover. Like I said, this was kind of a unique aspect of this particular campaign. I personally was very surprised when I learned this. Like I wasn't necessarily on the front line learning what this was happening. I was just kind of reading the retrospectives, and this was something that really surprised me. It wouldn't have been something that I necessarily expected to happen. And notably, if your Maven packages are compromised, that introduces the opportunity for things like the NPM packages to once again be compromised. So thinking that, okay, you've solved the problem in one ecosystem means that you're safe is an unsafe assumption in this particular case. All right, so point I'm trying to make here, the thread is still evolving. And in fact, last week or maybe 2 weeks ago, something in there was a new malware campaign that was nascent. It actually didn't really get off the ground, but it had all the hallmarks of Shai-Hulud, and it was caught early, which was great. There were some really interesting things here that went on. They were kind of setting the groundwork for kicking off things like typo squatting and things like that as a way to start this chain of events. It started interacting with things like with MCP servers, excuse me. So like AI coding tools are now interacting with this thing. There was, I don't think I have it in the slide here, but there was like exfiltration through DNS, which has been seen before, but kind of novel and not necessarily even something that you're looking to protect against at the the network level. So just making a benign DNS request can actually be something that that helps to exfiltrate these secrets. So very interesting. Here's the point I'm trying to make, which cues up the second half here. Post-install scanners are not always enough. Now, I'm not going to say that real-time scanners are enough either. I think we need to have defense in depth, and these are complementary tools. But there's a gap here that historically has not really been addressed. And so there's an opportunity to protect against these things a little bit better. We need interception before install. I'll leave it there. Okay, so this is where I'm going to talk a bit about the real-time package firewall. So let me just, I'll start here. As I started with, developers are interacting with their package managers regularly on a daily basis, many times a day. And so it's a frequent touch point. So what we did is we built this very basic wrapper around a package manager where you could prefix any given package manager command, and it would do things behind the scenes. And I'll get to the do things in a minute. It will intercept the network traffic. It will check with our source of truth, the mothership, and determine whether this thing is actually safe to install. And it will do that for every single package request that is sent out from your package manager to the registry. And it works across ecosystems. I'm not gonna belabor this. So this is probably where most of you all are interested, so I'm hoping I'm getting there fast enough. Starts with interception, TLS interception. We have the package manager, it makes a request to the registry, right? In between is this proxy firewall where it's an HTTPS proxy, meaning it handles the connect verb of the HTTP protocol. So it has to be configured, your package manager has to be configured to use this as an intermediary when interacting with the registry. But then all this traffic is flowing through it, and I'll dive into that specific piece in a couple of slides. So the request is intercepted. You get just like this basic path. You can associate it with a particular registry, so you know kind of what you're dealing with here, and that can be turned into a PURL, a package URL, which is kind of a standard way of representing a particular dependency in a unique way. And here we're fudging a little bit because there is a distinction between artifacts and packages. So like in the PyPI, Python world, you might have multiple downloadable assets for a package at version. But by and large, if you know the wheel is compromised, you're not going to want to download the other things either. So we just sort of normalize it to the package. And then with that PURL, we go to our policy engine, the mothership, as I said, and that determines whether a package is blocked or allowed. Now, I'll point out the obvious, because apparently that's what I'm doing. There has to be a source of truth for this to have any benefit at all. So I'm not going to say like this just magically solves all the problems. There has to be some mechanism that is in real time or near real time identifying these threats and marking them as threats so that they can be blocked in real time. But the kind of important aspect of this is this doesn't require any human involvement beyond maybe what happens in identifying that threat. There is a real-time aspect to this that as soon as the threat is understood, it is blocked. And that's basically the premise of this approach. So to give a little bit more insight into what's happening with the actual proxy itself. So it's a little bit arcane, and it's actually been hard to explain. So hopefully like the diagram actually helps to explain here. There's actually 4 streams of data. There is the inner HTTP, and this is probably what you're expecting, what you're thinking about when you're talking about a package manager interacting with a registry. This is where the package manager is making GET requests for tarballs and things, right? And then that's wrapped in TLS. Hopefully. Then in this particular case, the proxy is in the middle. So it is actually man-in-the-middling the TLS connection. It is doing TLS termination at that point in time, meaning that the package manager has to trust this proxy in order for it to actually be able to effectively decode that inner TLS, inner HTTP traffic, right? And then that is all wrapped in this connect transaction, which is another stream of data. And then that is wrapped in this outer TLS because when you're talking between the package manager and the proxy, you're going to want that to be encrypted as well. And so there's these layers of streams of data, these layers of abstractions that actually make this a little bit finicky when it comes to implementing the thing in the way that a package manager can interact with successfully. So. Okay, oh gosh, okay. All right, here we go. We're gonna just breeze through here. I'm gonna skip over this. I did not time this well, sorry folks. There's support for a number of different kind of facets of this. There's different types of registries, there's private registries, there's all these different things. So I'm breezing past the stuff that is interesting but not necessarily core to this. And we're gonna skip. Oh my goodness, this is great. CAS strategy. Okay, real world lessons, we made it. 5 minutes left. Yeah, we're cruising. All right, okay, here we go. Okay, so it works with NPM is just the beginning. Like that was actually where I started, just making it work with NPM. But there are a lot of ecosystems, and we saw before there's crossover, and we also want to kind of impose these guardrails without them becoming super opaque and actual obstacles to doing development work. We want them to kind of work magically, transparently, without interrupting the flow, without being a problem, right? So that's just the starting of where we went with this. And I'm going to talk a little bit now in the last few minutes about the quirks with some of these package managers, right? Cargo, if you're invested in the Rust ecosystem, is a fantastic modern package manager, but it has a quirk. If you specify that a particular root cert should be used when interacting with remote systems, meaning if we man in the middle of the traffic, the cargo package manager needs to know how to trust that traffic. Cargo has some interesting quirks. So as soon as that happens, we're man in the middling some things, but we probably don't want to just get in the way of every traffic. We want to get in the way of registry traffic and inspect that traffic. Unfortunately, Cargo doesn't really let you do this. It just kind of like, if you say trust this cert, it's like everything has to be signed by this cert. There is no traffic that will be permitted unless that cert is in the cert chain, right? So that's a problem because Cargo doesn't just interact with the crates endpoint. It also interacts with GitHub. It interacts with private registries. It interacts with other endpoints that are maybe telemetry endpoints or different things like that. And then all of a sudden this traffic's not working. And that's a problem for Cargo. So this was a wrinkle. Yeah, Yarn. Yarn is anybody in the room, have they worked on Yarn? Okay, I'm sorry. I'm gonna rag on Yarn. I'm really, really sorry. Yarn is a special snowflake. It has some really weird quirks, especially when it comes to interacting with a Connect proxy. So there's some benign things like, oh, it just deals with URL strings a little bit different. That's fine. This is the weird one. This is the one that really got me. Yarn is trying to interact with registry and npm.js.org. We're saying, hey, here's the root cert that you can use to interact with that. That's like stamped with a domain name, with a host name, right? But the outer TLS connection, the one I showed you before, between the package manager and the proxy itself, Yarn expects that to include the registry host name as an alt name. It doesn't make any sense. And probably nobody's run into this because nobody's tried to exercise Yarn in this way before. This is kind of a new approach. And so it makes sense. But we wanted to work without having to like change all the package managers in the world because that was a pretty heavy lift. We're not going to boil the ocean. We just wanted to get it to work. So this was kind of an interesting problem to solve. And there's some variations across Yarn versions. The newer ones are a lot more solid. The older ones are still in heavy use, and it gets a little bit funny. Yeah, Gem, if you love Ruby, okay. Sometimes, like just depending on like a patch version, y'all, it will just decide, no, I'm not going to interact with the HTTP proxy at all. So there's now like constraints that we have to communicate to people if they're trying to use these firewalls. Say, you actually can't use .4, you have to use .5 of this minor version of, so on and so forth, because Gem is just kind of like a little bit weird, and it also varies across operating systems because of how the SSL, the TLS layer that it's interacting with and using for fetching packages. Fortunately, Gem spec requests, which are not the tarballs themselves, but they do respect the proxy. So it's actually internally inconsistent in a way that was very fortuitous for us, where we could block that instead, and it ended up doing the job. Yeah, and then I think I'm just about at time, so I'm going to just show all of these on the slide. We kind of have two ways we've deployed this thing. One is as a service deployed in the cloud, and you can kind of just make sure everything talks to registries through the service. And then, as I showed earlier, we have a locally running command that you can prefix your package manager command with. It'll spin up this proxy ephemerally. It'll actually mint the root certs and place them in temp directory for the duration of that process, and then throw it away. And so to make this work when you're kind of across both of those paradigms, we have generally approached this, especially for the locally running one, the one that wraps it, we have approached that just through environment variable configuration. And it's a little bit of a zoo, as I titled the slide. It does generally work. There are some weird quirks and things like that, but because this environment variables will propagate through the process tree, it's even if you have npm commands running within npm commands and so on, everything still receives that ephemeral configuration for the process, the firewall that's running locally. Yeah, that was the last one on the slide. I'm at time, so I don't think I really had much else. Oh gosh. Let me just revise that. Wow. Yeah, I didn't time this, folks. I'm so sorry. Yay. Okay. All right. Yeah. Yeah. I had wrap-up slides, and we could skip those. I don't think I have time for questions. I want to leave time for the next presenter. So if you have questions, I'll be out and come and find me. Happy to chat.